Welcome to Everyday Mathematics. Today we cover problem 9 of the MIT Integration Qualifying Exam 2012, which is the definite integral from x equals to 1 to x equals to 2011 of the square root of x over the square root of 2012 minus x plus the square root of x. So this is a really interesting problem, to be honest. This was actually quite hard. Just had to use a couple of tricks, but I hope you do enjoy the solution. So problem 9, which is the definite integral from x equals to 1 to x equals to 2011 of the square root of x over the square root of 2012 minus x plus the square root of x dx. So I'm not going to use substitution here. I'm just going to use what we call SADs and then try to rationalize denominator and numerator. So the first thing I would do is I would say, okay, we have this fraction that is interesting. I don't want complex square roots in the denominator. So what I'll do is I'll multiply by the square root of, for those of you who know how to handle the square root, would be very familiar with this practice that I'm doing. So we are trying to get to the difference of two squares by multiplying the same thing we have in the denominator by changing the sign, so that this is the same as, because this one, the numerator here, this is the same as 1, right? But we need it because we want to pretty much simplify what is the denominator here. So then we have square root of x times the square root of 2012 minus x minus this square root of x times the square root of x is x all over, it is this times this minus this times this. So we have, in other words, 2012 minus x, right? So we come to out divided into two separate integral. So we have square root of x, square root of 2012 minus x over 2012 minus 2x, right? And then maybe the second integral here, I could write it in blue. Sorry, that's not 0, rather it's 1. So we have our blue integral x over 2012 minus 2x. So let's handle the yellow integral first, and then we go forward and handle the blue integral. So this is an interesting function that one can look at and deduce a couple of things, right? So here in the denominator, we have 2012 minus 2x. That means that this value is 0 when 2012 minus 2x equals to 0. So it's 0 at 1016, right? So looking at a plot here, at 1006, we have an asymptote such that we do have a function like that, right? And a function like that. This here is 1 over 2012 minus 2x, right? And the same thing here, 1 over 2012 minus 2x. Now, if we look at the denominator here, the numerator, sorry, rather. So the numerator here is going to be at 0, we have 0, right? At 2012, we have another 0. And if I use green, like that. So this is square root of x square root of 2012 minus x. So what that means is that this function is going to be something like that, right? And something like that, because it is symmetrical along the 1006. And so the area here up to 1 is the same as the area here. This is positive, but this is negative area. That means that the value of this integral, of the yellow integral, is going to be equal to 0. Right? So that is for the yellow integral. Now we need to look at the blue integral. The blue integral is x over 2012 minus 2x from 1 to 2011. This is the same as half x 11 of 1006 minus x dx. It is the same as half when you divide the numerator by the denominator, we have -1 plus 1006 over 1006 minus x. Let me see. Yes. Okay. And what is crucial here is for x values. So let's just continue here for a minute. So we're going to have the integral from 1 to 2011 of 1, and then let's use the let's call the next integral the green integral, which is 1000 minus x, right? So the blue integral for now, this is equals to so let's just say x 1 2011, which is 2010 over 2, because this minus this, which is equals to 1005. So we have dealt with the blue integral. Now let's look at onto the green integral, which is it's an interesting integral, a half of 1006 minus x. And if we look at the denominator alone and try to guess how that function is going to look at, this is from 1 to 2011. So at 1006 here, we have an asymptote, and so this function is going to look like that up to 2000. And since this is a constant, we see that the area here is the same as the area here, right? And this is positive area, negative area, and this is, by the way, 1006 over 1006 minus x. So this area cancels, the positive and negative cancel each other, so this is just essentially equals to 0. What our integral now becomes is the only integral that remains is the blue integral, and now we say that the integral from 1 to 2011 of the square root of x over the square root of 2012 minus x plus the square root of x is equals to 1005. What remained from the blue integral. So that is the answer. It's just requires a lot of knowledge on graphing. Better than that, yeah, that's our answer.